NVIDIA BioNeMo powers end-to-end AI drug discovery pipelines with instant, seamless access to generative AI and large language models. An AI-powered cloud-based service, it provides pre-trained models with billions of parameters at supercomputing scale. These models include generative chemistry with MegaMolBART and MoFlow, protein language models to generate learned embeddings for protein structure and properties with ESM1 and ESM2, pose prediction with DiffDoc, protein generation with ProtGPT2, and deep learning models for 3D protein structure prediction with OpenFold, AlphaFold, and ESMFold. BioNeMo is based on NVIDIA NeMo Megatron and provides what researchers and developers need to quickly build and deploy generative AI drug discovery pipelines, including a robust set of libraries and tools that streamline the process of model development. These include functions for automatic data loading and pre-processing, examples with model configurations and scripts to quickly build pre-training and fine-tuning pipelines, documentation that details the step-by-step process of running training and inference tasks, and an extensive API for simple integration into custom applications. Let's take a look at the configuration for training the ESM1 model and see how we can quickly configure and run a multi-node training job on NVIDIA DGX Cloud using Base Command platform. NGC is a public catalog that offers access to the NVIDIA AI Enterprise software suite, containers, Helm charts for deployment, pre-trained models, and resources like the NGC command line interface. NGC also gives organizations access to a private registry where they can store their own private collections of containers and software. NVIDIA Base Command platform includes a central user interface with a set of managed compute resources. This can be used to manage datasets, workspaces, and jobs, as well as users and teams within an organization. This creates a convenient hub for monitoring job execution, viewing metrics and logs, and monitoring resource utilization. The reference script that we'll use can be run locally to launch a job using the NGC CLI. The NGC and BCP run commands generated by the script can also be used in the NGC web UI to configure and launch a job interactively. Here we can see the layout of the BioNeMo library, with the core functionality in the BioNeMo directory, a set of pre-trained models in the Models directory, and a set of sample scripts and configurations in the Examples directory. Now let's look at a reference script to launch a 2-node training job on Base Command platform. Here we'll configure the BioNeMo ESM1 training command to run pre-trained small with the UniRef dataset as input. We'll also define the experiment workspace, number of nodes, and GPUs per node, and other parameters like batch size and training steps. The training command defines the ESM1 workspace and configures the pre-trained command to include the input dataset and data files, the experiment directories, as well as the parameters of the run, including batch size, the number of training steps, validation intervals, number of workers, and other parameters. The BCP run command is used to launch the multi-node training on Base Command platform, specifying the number of nodes and the number of GPUs per node. We then tie it all together with an NGC batch command. This is where we define our organization and team, the accelerated compute environment to be used, the instance type, which in this case is NVIDIA DGX A100s, the number of replicas or nodes, the workspace, and other job parameters like max runtime. We then execute this script to submit the job to NGC and kick off training on Base Command platform. Here we'll see the output from the NGC launch, and then we can verify in the Base Command UI that our job has been submitted for execution. After launching the job using the NGC CLI, we can monitor its status in the BCP jobs pane. In this example, we can see the command used to launch the job. We can view telemetry showing resource utilization during the run. We can look at the replicas or nodes that were used to execute the training, and we can also view logs produced during the run. This central overview gives developers a simple way to evaluate performance and efficiency of jobs over the course of many experiments. In this walkthrough, we've demonstrated the BioNeMo tools that allow researchers and developers to pre-train and fine-tune their own custom models using the BioNeMo training framework. We then showed how easy it is to execute these models in Base Command platform on DGX Cloud. To learn more about BioNeMo, Visit NVIDIA.com to join the Early Access program.